The first exercise is related to the payback period. Now, we mentioned in the lecture that we have two types of payback period. We have the simple payback period and the discounted. This one is related to the simple payback period. Let's read it together. Here I have this cash flow series, and I'm asking how many years will it take to recover an initial investment of $800,000 using the simple payback period. So my initial investment was $800,000, and I have a series of cash flow in the upcoming years, and I want to know when did I get back the initial investment that I have paid. How many years did it take me to get it back? So with the simple payback period, I'm not taking into consideration the time value of money. So I'm not multiplying the numbers that I have in the future with any interest rate. So as if I am saying only that I'm getting the summation of the values that I have here. So starting from the $8,000 that I paid, so it is a minus $800,000. What will I do? I will just add the $250,000. The final answer will be minus $550,000. Then I will just add to it the $400,000. The final answer will be minus $150,000. Then I will add the $300,000. I will get a positive value which is equal to $150,000. So what did I do? I just summed up the values that I got in the table, and I will see at which year will I start getting a positive number. So if you look at the column number 3 related to cumulative present worth at 0, the first value was minus 800, second row I had minus 550, third minus 150. Then at year 3 I got a value of plus $150,000, which is related to n equals to 3. So as if I'm saying, if I will have an investment of $800,000 and I will have the following cash flow series, then it will take me 3 years to get back the money that I paid. And since this number is slightly greater than 0, so actually it took me a period which is less than 3 years. It's between 2.5 and 3. So this is what I get by using the simple payback period. But of course, this is not accurate because I have to take into consideration the time value of money. But this is a method that's used just to give you a number right away. You will say, okay, adding all of the values, then I need at least 2.5 to 3 years to get back the money that I invested. Now what if I want to solve the same exercise, but this time I want to use the discounted payback period, which takes into consideration the time value of money and provides an interest rate of 12%. How will the solution change? Let's see. So here with the discounted payback period, I want to take into consideration the time value of money. So I'm gonna use an interest rate of 12%. So what will I do? In the second column, I will put the values that I have, the minus $800,000 at year 0. This is my initial investment. At year 1 till 4, these are the cash flow series, the amounts that I'm gonna get. So I want to get the present value of all these amounts. I want to get them back to the present at interest rate of 12%. So what will be the value of the $250,000 occurring at period 1? If I want to get its present value, I will be using the equation P equals F into P knowing F 12%, 1 because it's far away by 1 period. So I'm going to get the present value of each of those payments. The $400,000 is far away by 2 periods. So the present value of it is 400,000 into P knowing F 12% 2. The present worth of the 300,000 is 300,000 times the P knowing F 12% 3 because it's at year 3, far away from the present by 3 years. In the same manner, I will get the present worth for the $450,000, multiplying it by the P knowing F 12% for. So now I get the values at column 3. Now I can do the summation, and I do the cumulative value of all these payments. So at column 4, I will start with the $800,000, and I will say minus $800,000 plus the $223,250 that I got from the present worth at year 1. I will get the value. The value is still negative, minus $575,000. Then I will get the next. I will add with the next number, which is $318,800. The final answer is still negative. I will add the third value, which is $213,600. You will see that the value is minus $42,600. It's still negative. So I add to it the last number related to $886,200. Now, at last, you will see that I have a positive value. This means that the discounted payback period was equal to 4 years. So you see it's slightly larger than the end that you got from the previous example, where I didn't take into consideration the time value of money. So this is more accurate, and it is a rough estimation to tell you that I need 4 years to get back the initial investment that I paid. Now another exercise related to the payback period. Here I have an investment that will cost P. So the initial investment is in terms of P. I don't know what is the value exactly. It is expected to have an annual net cash flow of 0.125p for 20 years. So each year I'm gonna get 0.125p. So everything is in terms of P. What is the payback period? Here I didn't say the discounted payback period, so you have to understand that this is the simple payback period. Now I can begin and put the values in a table. So at 0, the initial investment is minus P, and each year I'm gonna get the value of plus 0.125p for the upcoming 20 years. But I need to know at which year will I get the payback. Now, since here I have a P value, I don't know what's the number exactly. However, the cash flow series is a fixed number. It's not a different, it doesn't have different value as the previous exercise. At each year I had a different amount that I'm earning. Here I'm earning equal amounts of 0.125p. So instead of tabulating, I have an easier, quicker way. I will put it in terms of an equation. I will say, how many years X do I need to earn 0.125p to get the value of P? So as if I'm saying P equals 0.125p times X, number of years that I need in order to get back my initial investment. So simply I can say X equals, by cancelling P from each side, X will be 1 over 0.125. So I will be needing 8 years at which I'm earning 0.25p in order to calculate the total investment that I paid, which was P. So you see, you can go for this method when you have constant values each year. It's easier for you. Now I want to solve an exercise which is related to the IRR. We have solved many exercises related to the IRR in the lecture. They are enough, but this idea is a little bit different, so that's why I included it in the sheet. Let's read the exercise together. Here you are considering a mining operation. The cash flow pattern is unusual since you must invest in some mining equipment, operate for 2 years, then restore the site to its original condition. So you might see that the numbers are a little bit unusual. Ignore it. You estimate the net cash flow to be as follows, found in the table. And I'm asking, what is the approximate rate of return for this investment? First of all, you remember that the starting point for getting the IRR is always putting present worth equals to 0. What do I do with the values that I have in the table? They are future value, and I want to get its present. I see each period, how far is it, by how many periods. Use the equation as we used to do. So I'm gonna put the equation in this form. Present worth equals to minus 1,600,000. It is already on the present, so I don't multiply it with anything. Plus 1,500,000 into 1 plus I to the power minus 1, because it's far away by 1 year. Plus 1,500,000 into 1 plus I to the power minus 2, far away by 2 periods. And the 700,000 into 1 plus I to the power minus 3, because it's far away by 3 periods. I'm going to put this equation equals to 0. Now we notice here that I have so many zeros. So since this equation equals to 0, so I can cancel these zeros altogether. And I will assume that the 1 plus I to the power minus 1, I will assume it to be equal to x. So the formula will look like this. Minus 16 plus 15x. You see, I cancelled 5 zeros, okay, from all of the values, and since the right side is equals to 0, 0 over 0, so I can do it. So I will have this equation, minus 16 plus 15x plus 15x squared, since I assume that x equals to 1 plus I to the power minus 1. And here I have 1 plus I to the power minus 2, so as if this is x squared. And minus 7x cubed. So this is the simplest equation. I will put it equals to 0, and using the calculator I will get 3 solutions for x. Now, how do I know which is the accepted solution and which are the rejected ones? In order to know that, I will have to get the limit for x equal 1 plus I to the power minus 1. Okay? Now, this is the same as saying x equal 1 over 1 plus I. So what is the limit for 1 over 1 plus I? When I equals to 0, what will be the value? 1 over 1 plus 0. So the value is 1. So this is the limit when I equals to 0. When I equals to 1, I have 1 over 1 plus 1. So 1 over 2. So this is half. So I have the limits for 1 over 1 plus I, which is the value of x. It should be in between half and 1. Let's look at the previous solution that I got. I have x equal 2.6. This is outside the limits, so it is rejected. Then x is minus 1.2, outside the limits, rejected. X equals 0.721, it is within the limit, so this is x that I will accept. Now I'm not done with the solution. I only got that x equals 0.721, which is the accepted x. But remember, I want to get the IRR. We got that x is 0.721, and I know that x is 1 over 1 plus I. So I equate those numbers, and I will be able to get I, which is 0.38 or 38%.